This Venn diagram problem will make you very proficient in probability questions because it has quite a number of questions which are very useful. So let's examine this diagram here, Venn diagram. It's unusual in the fact that it doesn't look like the usual three set diagrams. Set A, set B, and then a set 3 which has no connection with set A. So we're told that each set represents a popular magazine, A, B, and C. And the numbers inside it show you the number of students in a class who read any of these 3 popular magazines. One of these students is selected at random, and we are to show that the probability that that student reads more than one magazine is 1/6. And I can see that 2 people read magazine A and B, and also 3 people read magazine B and C. So these students, 5 students, read more than one magazine. So the probability of one of these students reading more than one magazine will be 5, that means 2 plus 3 students, and we need to take this over the whole population of the class, which happens to be, if I add them up, 10, 16, 21, 24, 24 and 6 is 30. And remember, it would be rude not to cancel this down into 1/6, which is precisely what we have. This is what we needed to prove. Now we've got another problem here where we want to find the probability that the student reads A or B or both. This or both is superfluous. That means it's totally unnecessary, because if I say A or B, then what I mean is the probability of A or B, which is exactly the same thing as saying the probability of A union B. So let me bring down the Venn diagram so we can see it. And the area that unites A and B is the whole of A and all of B. Goes right down over here. This means this segment, this segment, this segment, and as well as this segment. Now you can see when I said that or both is unnecessary, because this is both. And so that probability will mean that we have 4 plus 2 plus 5. We also have 3 because 3 is also part of magazine B, students who read. Now, because it's a probability, we need to divide it over the whole class of students, which is 30. And that will be 7/15. And we cannot simplify this, so it will just stay as 7/15. And this question is a little bit unusual, so it's worth doing. Write down the probability that the student reads both A and C. When we write both A and C, then we write because and probability of A and C means that we're looking for the probability of A intersection C. Well, let's have a look at what numbers there are. Where is the intersection? If we look at that intersection, we see that set A is here and set C is here. They don't seem to be intersecting. They're nowhere near each other. So we will say that the probability is 0. Well, we could write over 30, but it's not going to make any difference. It is 0. The next problem is a conditional probability problem, and these kind of problems can be a challenge to us. I feel it might be worthwhile me doing another video on how to solve conditional probability problems, but in the meantime we'll just do this problem. it would be lovely if you would help me out by subscribing to this channel and also giving it a like. Okay, we have got a problem where it says, given that the student reads at least one of the magazines, find the probability that the student reads magazine C. And we can write this as the probability of magazine C being read on condition that at least one magazine was read. And this vertical line here is the one that says on condition. The fact that a student had to read at least one magazine narrows down the whole sample to these segments over here, 3 and 6. These show you the number of people who have already read one magazine. And so the probability that a student will read magazine C, given that at least one magazine was read. Let's look at the denominator first and have a look how many people have read at least one magazine. Well, that would be everyone here in yellow. 4 plus 2 plus 5 plus 3 plus 6. I'll write that down underneath here. 4 plus 2 plus 5 plus 3 plus 6. And now, how many people read the magazine C? That would be, if I draw this in another color, people in here and in here. So we've got 3 plus 6. 3 plus 6. And that will give me 9 out of 20. And this cannot be cancelled down anymore. So that is the answer.